necessary conditions and their refutation. The general said, "The rule of law is a necessary condition for enduring peace." The philosopher said, "Being falsifiable is a necessary condition for a theory to be scientific." From a logical point of view, what did they each mean? We're going to focus on the philosopher's example, and by the end of the video, you'll be able to state clearly what the general meant, because both statements have the same logical form. You'll also be able to state what you need to show to refute the general and the philosopher. The philosopher said, "Being falsifiable is a necessary condition for a theory to be scientific." What the philosopher meant to say was that if the theory is not falsifiable, then it is not scientific. Let's dig a little deeper. We'll use some symbols to make the logic of what the philosopher said more obvious. Let's use the letter F for the sentence, "The theory is falsifiable." And let's use the letter S for the sentence, "The theory is scientific." We'll also use two other symbols. An arrow for the phrase "if then," which we can also express by saying blank only if blank, and the bench or neg symbol for not, or the phrase "it is not the case that." As we've already seen, when the philosopher said being falsifiable is a necessary condition for being scientific, that means that if the theory is not falsifiable, then it is not scientific. So we can write this as neg F arrow neg S, or if not F, then not S. However, we know from elementary logic that the sentence not F only if not S is logically equivalent to the sentence S only if F. But the sentence S only if F is just a symbolic version of the sentence "the theory is scientific only if it is falsifiable." So when the philosopher said being falsifiable is a necessary condition for being scientific, we could also say that the philosopher meant that the theory is scientific only if it is falsifiable. Now suppose we want to refute what the philosopher said. We have to show that it is false that being falsifiable is a necessary condition for being scientific. From what we've learned, we know that that's the same as showing that the following statement is false. If S, then F. To show that the statement if S, then F is false, we just have to find an example in which S is true and F is false. So, to show that being falsifiable is a necessary condition for a theory to be scientific is false, we have to find an example in which it's true that the theory is scientific, but it's false that the theory is falsifiable. And that's how you refute a claim that one thing is a necessary condition for another. In general, then, when someone says Y is a necessary condition for X, that's the same as saying if X, then Y, which we could also read by saying X only if Y. To show that if X, then Y is false, we just need to find a case where X is true and Y is false. So we refute the claim if X, then Y by finding a case in which X is true and Y is false. So now you can figure out both what the general said and what you would have to argue to refute the general.